So now the last speaker of the session, Jordi Riba from Barcelona, will be talking about ayahuasca from EEG and Imaging studies, and now we are back in humans.
So, good afternoon everyone. I would like to thank first the organizers for inviting me to tell you about the studies we've been conducting these last 15 years in Barcelona. And I'm going to talk about ayahuasca, and besides some older data that's already published, I'm going also to present some new analysis we've conducted on EEG measurements of brain electrical activity we've done in humans, and also results from neuroimaging studies. So, for those of you not familiar with ayahuasca, ayahuasca is a plant concoction, is a psychotropic plant tea, which was used originally in the Amazon by combining two different plants. It induces a transient modified state of awareness that lasts around 4 hours. This was used traditionally by the indigenous peoples of the region, but in recent years, ayahuasca use has spread worldwide. This is because some syncretic religions have appeared in Brazil, which combine Christian beliefs with ayahuasca use, and they have spread their activities to many foreign countries in North America and in Europe. So contact with ayahuasca is much easier right now than it was like 20 years ago. Many people are attending these sessions. Shamans are coming to Europe and organize sessions, and many Europeans and Americans are now members of these religions. So the plants that are used to prepare ayahuasca are these plants I'm going to tell you about. The first is Neuropsychopharmacology. This is a vine, a climbing plant, and it was described botanically in the 19th century, and for many years it was thought that it was in this plant where the active principles of the ayahuasca brew would be found. So many analyses that were conducted on ayahuasca were actually conducted on the ayahuasca vine, on Neuropsychopharmacology. And although it contains some physiologically active compounds, the main visionary compound is not present here. It was other investigators, like botanist Richard Schultes, who discovered or reported that many other plants were added to the brew in combination with Neuropsychopharmacology, especially the leaves of this bush, Psychedelic viridis, and it's in this bush that the main visionary compound of ayahuasca is found. So initial analysis on the alkaloid contents of the vine of Neuropsychopharmacology found an alkaloid which was tentatively named telephin in the beginning of the 20th century. Later, independently, another researcher could isolate an alkaloid he called yahein. This is because ayahuasca is known as yahe in other countries in South America, like Colombia. And later, another researcher isolated what he called banisterine. And banisterine was used for many years in the treatment of Parkinson's disease until L-DOPA was available. So it was later in the 1930s that they found that all these compounds were no other than harmine, which was an alkaloid that had already been found in the seeds of another plant, of a European and Asian plant called Pegana marmala. So in Neuropsychopharmacology there was harmine, but there was also harmaline and tetrahydroharmine. So these three compounds are known generically as beta-carbolines. And the leaves of Psychedelic viridis contain this other compound, totally different compound. It's dimethyltryptamine. This is a psychedelic. It's a 5-HT2A agonist. So in a typical ayahuasca brew, we'll have DMT, which is a powerful psychedelic, but that interestingly is not active when it's taken orally, because it gets degraded in the gut by an enzyme called monoamine oxidase. But these other alkaloids, the beta-carbolines present in ayahuasca, are potent monoamine oxidase inhibitors. So what we are going to have here is an interaction. If DMT were to be taken orally alone, it would be destroyed in the gut and the liver. But if it's taken with harmine and the other beta-carbolines in ayahuasca, it reaches systemic circulation the central nervous system, and interesting effects appear. So we decided we wanted to study ayahuasca, and ayahuasca, as it was being taken by all the people who were getting involved in the ayahuasca religions and all these ceremonial practices. So we didn't want to use the pure compounds, let's say like DMT combined with pure harmine. So what we did is try to develop a formulation that would allow us to administer ayahuasca in the controlled designs, administering placebos, inactive placebos or active placebos, and in accurate doses. So what we did was we freeze-dried ayahuasca, we measured the alkaloid contents, we encapsulated, and we developed this formulation that we afterwards could use in our clinical trials. So here you have the average volunteer with his lucky t-shirt about to ingest the capsules in a clinical study. So we've already conducted like 3 or 4 acute administration studies of encapsulated freeze-dried ayahuasca. We've converted with placebo, with active compounds. We've measured subjective effects, tolerability, cardiovascular variables, many different things. But what I'm going to tell you about here today is what we've found measuring spontaneous brain electrical activity first. So here, what I'm showing you is the results for a statistical comparison. These circles here represent the head. The white dots are the places where electrodes are placed on the scalp. So we measure spontaneous brain electrical activity, and we calculate the energy, what's called the power spectrum in the different frequency bands. So this is a multivariate analysis of all the frequency bands combined. And what we see here is that we find a clear dose-dependent effect. So at different time points, 45 minutes, 1 hour, 1.5, 2 hours, 2.5 hours after ayahuasca administration, we see that the effects after a higher dose, 0.85 milligram DMT per kilogram body weight, exerts more potent effects than this threshold dose, than this lower dose. And the most intense effects, the higher significance, the warmest colors, we find between 1.5 and 2 hours after administration, which coincides with big concentrations of DMT in blood and also with the big subjective effects. So after doing this global initial analysis to see where the most intense effects would be found in time and at which dose, we wanted to study the changes or the effects of ayahuasca on the different frequency bands and try to localize these changes on the brain, in the brain. So by measuring the what we call the topography, the scalp distribution of the changes in voltage, we can compute changes in current density inside the brain by means of this technique. It's called Loretta. And by doing so, we were surprised to find widespread decreases in power in different frequency bands. So here, what you see is the results we obtained for the delta band. This is slow activity. So we found areas where slow activity was clearly decreased. These areas were predominantly posterior in the parietal, occipital, and temporal lobes. So here we found decreases in the middle temporal gyrus, in the superior temporal gyrus, in the precuneus, and in the fusiform gyrus. So no one had looked at EEG for 25 years or more when we did this, so we were surprised to find decreases rather than increases. It fit well where we found the decreases with the changes the subjects were reporting, but not with the brain imaging results that have been obtained using PET or SPECT with psilocybin or mescaline. When we studied the theta band, what we found were also decreases here in the middle temporal lobe, in the hippocampal gyrus, and some changes in anterior brain regions, mainly in the anterior cingulate, in the medial frontal gyrus. And finally, this beta 1 band that goes between 13 and 16 Hz also found decreases, and these were located in the precuneus and in the posterior cingulate. So this we published in 2004. And basically, how we interpreted these results was that we were seeing changes in current density in the areas that were associated with the processing information that comes from specific sensory modalities. So we have here what's called the visual, somatosensory, and auditory association cortices being involved in these changes, and also what's known as transmodal areas. So these are areas that bind the information from different sensory modalities. We have the temporoparietal and frontal intermodal association cortex, and also limbic regions, the anterior cingulate, and the parahippocampal gyrus. But as I said, these results did not fit with the data that had been published with PET and SPECT following psilocybin or mescaline administration. So what we did next was a neuroimaging study using SPECT. And here we basically found increases in blood flow. We didn't find decreases anywhere in the brain. And these increases were located in the frontal cortex and in the anterior cingulate, in the insula, and in the parahippocampal gyrus and the hippocampus. So there's only partial overlap between the results we are obtaining using one technique and the other. So we don't see, by using SPECT, any effects on unimodal association cortex, but we do find an overlap in transmodal areas, basically frontal intermodal association cortex and the limbic regions, the anterior cingulate and the parahippocampal gyrus. So later, more recently, we've conducted what we call a repeated dose administration study with ayahuasca. We've given 2 doses of ayahuasca in a 4-hour interval. So after the first ayahuasca dose, we also measured EEG. We calculated this current density distribution at all these different time points. So here is the first ayahuasca dose administered, and again, we replicate these posterior decreases in current density. These effects disappear after 4 hours, and when we administer the second ayahuasca dose, we again see these changes. So we've replicated in several studies these decreases we see with EEG. As I said, no one had done this with psychedelics until Robin studied this with Meg, so I was also glad to see that he found decreases using this technique, which is closely related to electroencephalography, and to see that perhaps these changes are robust and common to most psychedelics. So if we have to compare what we find analyzing current density or SPECT, we see that we have changes in association cortex pertaining to the visual and auditory sensory modalities, and this could explain the perceptual modifications that persons report when they are under the effects of ayahuasca. Using also the analysis of current density, we see these increases in heteromodal association cortex, which could explain phenomena like synesthesia. The changes in limbic areas that we see with both techniques, current density analysis and SPECT, could explain the memories that are typically reported by the subjects, also the affective modifications. And the increases in blood flow we see in the insula and the frontal neocortex, and that we only see using SPECT, could explain all these effects that are also reported by participants in studies, which is this increased interoception, all the insights they have under the effects of ayahuasca, this sensation of understanding or of a better understanding of reality having meaning, and sometimes even this can be quite intense and be experienced in the form of a revelation. So there's a partial overlap. One technique, EEG analysis, show us basically changes in posterior brain regions. We have the SPECT studies showing effects mainly frontally, and now what we have just recently started is doing another kind of analysis of the EEG data. What we are trying to establish here is causal relationships between the signals we measure at one lead and the signals we measure at other leads. So we are using here, we are doing a functional connectivity study here, and the measure we are using is called transfer entropy. So what we see here under the effects of ayahuasca is that there's a decrease in the connectivity, or in the information transfer between anterior and posterior brain regions, or anterior and posterior leads. So this is recorded at scalp level, and we can identify what we call the source areas involved in this decrease, and the target areas that are involved in the decrease. So there's less connectivity between the frontal and the posterior regions, and this can be interpreted as a decrease in the information transfer between these regions. So in a way we could also speculate here that perhaps top-down regulation is being decreased under the effects of ayahuasca. And using this technique, we see that both regions, anterior and posterior, can appear together in a single analysis. In combination with this decrease, we also saw increases in posterior to anterior connectivity. So here, the source areas involved in this increase would be posterior, and the target areas involved in the increase would be anterior. So there was a decrease of top-down regulation, and perhaps there's an increase in bottom-up regulation or information transfer. And all these results I've shown you were obtained in the acute administration studies, but we have also started assessing long-term users of ayahuasca. We've conducted psychiatric interviews, we've administered a battery of neuropsychological tests to a series of long-term ayahuasca users, around between 60 and 100, I cannot remember the exact number now. And we didn't see any deficits in this population, and we also did some MRI study. We did functional MRI, we did DTI, and also what we did was analyze the structure of the encephalon. So here what we did was study cortical thickness in these subjects, and what I'm showing here is the result of the statistical analysis between the long-term ayahuasca users and the controls. And what we see is that there are some regions, especially medial posterior regions, which show a decrease in cortical thickness, and other regions that are located medially in the frontal lobe that show increases. So again, these two areas emerge as being related to ayahuasca use, not acute ayahuasca effect, but long-term ayahuasca use. And additionally, what we checked was whether there was any relationship between changes at this level and their lifetime exposure to ayahuasca, so the number of times they had taken ayahuasca. And we do find a negative correlation here in the areas in the posterior cingulate cortex where we see this decrease, and a positive correlation in the area where we see this increase. So by using these new techniques, this functional connectivity analysis, and also this study of long-term users, again, these two regions emerge, anterior cingulate and posterior cingulate cortex, that perhaps if we take the results together with what's been reported for psilocybin, this may be two important hubs of activity for the effects of psychedelics. And to finish, I would like to thank my collaborators in Barcelona, the Polytechnical University. They did the functional connectivity analysis, and we also have a collaboration with a university in Brazil, and thanks to you for your attention.
Can you elaborate more about the UFRN study? Because I think it's quite interesting, the study of Andrade on Siddhartha about the visual cortex in ayahuasca, and what he spoke about. So can you give some details about it?
Well, they found activation in the visual cortex when subjects were asked to remember an image they had been shown previously. If I remember correctly, that was the study they conducted, and they found that under the effects of ayahuasca, the primary visual cortex was more activated than under placebo. But yeah, it's always difficult to draw a general conclusion because in our study, in the SPEC study, we didn't find any activations in the primary visual cortex, but we didn't impose any task on the subjects. They just had to remain with their eyes closed, both on the day they received placebo and the day they received the ayahuasca. And this is again at odds with what's been found for psilocybin in the BOLD study, in the fMRI study. So I don't know what the truth is.
Thank you. I knew that the numbers are quite small, the long-term users, but are you able to say anything about the incidence of common psychiatric disorders in that group, such as depression?
We screen them to rule out depression or any psychiatric or neurological disorder. And it was 20 volunteers who participated in the MRI study.
So when you say you screened them?
Yeah, we interviewed them. And
so anybody who had psychiatric disorder, you would not include, is that right?
we didn't, we only excluded 2 people, if I remember correctly, but because of some neurological condition.
I was just wondering.
Yeah, but of course there's always a selection bias, because you say you want to study long-term ayahuasca users and then people show up. You don't chase them around. So it's the people who wanted to participate, the ones you are able to study. So perhaps if someone had a bad experience with ayahuasca the first time they took it, they never went on taking ayahuasca, so they are not available for assessment 20 years later. So there's a bias, of course, in this population.
I was wondering whether there's any protective effect that you obviously can't say from that.
We are planning to start a new study in which we are going to interview people who are going to get involved in an ayahuasca religion. People so we are in touch with the members of Santo Daime in Spain, and anytime anyone will apply for membership or for participation, we will interview them and we will follow them for 3 years.
Wasn't any correlations with any personality trait measures or Beck, depression, inventory? You didn't do that with the great method changes to biology?
We haven't looked at that yet, so this is preliminary data.
The question I really wanted to ask is not really questions to open up to anyone who might have the answer, but so if you have a compound which, or a class of compound psychedelics, which seem to decrease oscillatory power, broadband decreases, that's pretty robust, and so you get, we've seen decreased blood flow in bulb, but and other studies have found increased glucose metabolism. I just want to open it up to anyone who might be able to solve that, because I can't. That you would see if you get a drop in, synchrony in the cortex, yet you're seeing an increase in glucose metabolism. I could fathom that being possible. I also think there's probably a mapping between, especially when we see it in such consistent regions, with the drops that we're seeing in blood flow, that's in the posterior cingulate cortex, and we're seeing drops in oscillatory power there as well. And that makes a lot of sense to me. What I want to get my head around is how you can have these effects and have increased metabolism of the brain. It makes sense that could happen, but I wonder if there's anyone in the audience who could sort of inform this discrepancy between the results that different teams have found.
Well, I guess we should be happy that at least the same regions show up in different studies. Even though in some studies we see decreases in BOLD and in others we see increases in blood flow. But as the previous speaker said, this is still work underway to try to understand better how the BOLD respond.
One consideration I have is that a lot of the measures are kind of summaries over time, and that's why I quite like these functional connectivity measures, and especially like Enzo was looking at variance over time, because in a way they're more state measures. I think you can lose a lot of information by making a summary over time. That there's there's been this change over a chunk, quite a large chunk of time. You don't really get in and see what's fluctuating within that time. Anyway.
Yeah, in this functional connectivity analysis we've analyzed at different time points over time, and the relationship between the frontal and posterior regions keeps changing the direction of the information flow. But it's those regions which are involved in the change.
Me?
Yeah, that may.
Oh, sorry. So the one difference, of course, between ayahuasca and anything else is that you've got monoamine oxidase inhibitor present. And there's two questions really. One is that particular enzyme blocker, does it get into the brain?
We didn't see it in systemic circulation. We didn't find harmine in most of our volunteers. And what we found was harmone, which is the degradation product of harmine. So it gets very quickly metabolized, at least harmine. We could measure tetrahydroharmine and harmine.
Because harmine itself, if it did get in the brain, has quite profound effects on dopamine and noradrenaline. So
Yeah, of course, it's a monoamine oxidase inhibitor. So ayahuasca is not a pure compound. You see a combination here of pharmacological effects. You see the effects of DMT plus the monoamine oxidase inhibition.
my question to you is, have you or anyone done a harmine arm
Harming arm
of the study? Because that's the control. And harmine itself is actually quite a fascinating drug, and I just wonder if you've ever studied it. In fact, you're in a position to study it because you presumably got it.
Yeah, we would like to do that because harmine and the other beta carotenoids were studied in the 1960s, and different researchers published contradictory results, and we would really like to look at that. But until now, we've looked at ayahuasca as a whole.
The decrease in activity might part particularly in research where people are not active but in a state of rest, might be partly due to that. And if participants were given a stimulating activity, one might find more activity than in a placebo.
In our studies, we controlled vigilance when we recorded EEG. We did not allow subjects to fall asleep. You can control this by measuring alpha. And in the SPECT studies, they had to remain with eyes closed for like 10 minutes after the injection, which is the time it takes for the tracer to distribute the brain. But they were not doing any active task.
Yes, I mean, I feel one might get a more realistic reading if one has a stimulation as well as lying in rest in the fMRI test.
There's this study that Claudio and the Brazilian group have conducted in Natal, and they had an active task and also resting. And I think they presented the resting results in Oakland, and they also saw decreases in both. So, but in the active task in which they had to remember these images they had been presented, they found greater activation of the visual cortex.
Well, but what is the significance of the thinning or thickening of the cortex?
I really don't know. But really, these participants were not damaged from a neuropsychological perspective. They even scored better than the controls in other tasks we administered. But as I say, there's also this selection bias. We could only test people who volunteered to participate and who had been using ayahuasca for many years, so perhaps they did not find that taking ayahuasca was detrimental to them.
consult a psychiatrist. Many years ago, I had a patient who lived in South America, it was a rural tribe, a very bright young man who had taken ayahuasca, he had learned their language, and so on, talked to them a lot about it. And he said that to have a synergy effect was interesting, but not what they were looking for at all. What they were looking for was the near-death experience. They used to take it every 6 months to a year and be very ill for about a day. And he said he found that very helpful psychologically in the long term, as did they. He said that he said to me something along the lines that you can't really live until you've been near death. Would you like to comment on that? And perhaps whether one's looking at the wrong dose level for ayahuasca for these drugs benefit within psychiatry.
I've seen people passing out during ayahuasca sessions in field studies. I don't know if that's what they understand under near-death experiences. But there's many different individual approaches to ayahuasca. Some people are there for the visions, the insights. The members of the ayahuasca religion say that ayahuasca provides them with, helps them in their life path. And traditionally, many shamans in the Amazon used ayahuasca to fight each other. So, and also to treat patients. So there's many different approaches. And now that ayahuasca has become even more popular, and many more people are getting access to ayahuasca, the approaches to the experience can be as varied as the individuals.
A similar question in a way. The totality of the ayahuasca experience is very much about the drug, but also the ceremony and the environment in which it's taken. Has anyone done any randomized placebo-controlled studies in which they give people placebos, but still have the ceremonial aspect, to see to what extent it's the drug and to what extent it's the environment?
Not that I'm aware of, but of course we could not reproduce an ayahuasca session in the laboratory, but to most participants the experience was very introspective, and they could totally concentrate on the inner experience and simply forget about us and all the surroundings. So they were less bothered by us the day they had the ayahuasca than the day they had the placebo, and we were constantly drawing blood or measuring blood pressure or temperature or whatnot. So no one has conducted a study until now on that. But I don't think taking ayahuasca in the lab was that disturbing to the participants.
I was going to come related back to Robin's question, and sort of, a situation which you can have increased glucose.
Can you speak louder?
Sorry, you can get increased glucose metabolism and not see a change in blood flow if there were alterations in neuromuscular coupling. So you might see a situation where you were GABAergic neurons firing, which might not a massive amount of the control that neurons exert over blood vessels is via glutamate via astrocytes. So if you've got neurons that aren't releasing glutamate, you can see that you can envisage a situation where you would have an increase in metabolism because most the neurons are metabolically active but they're not speaking to the blood vessels. Where you might get a decrease is a bit more hard to say, but you might get a situation where if you've got a dirty drug like psilocybin that might cause vasoconstriction, you could have vasoconstriction which is causing a decrease in blood flow coupled with this increase in metabolism. But that's probably why it's important to look at the temporal type of things like you were saying, like condensing the data into a blob and a brain map like we do isn't very important, or it isn't very helpful in that sense. You want to see whether you're getting vasoconstriction before you're getting neural effects, for instance. So we've looked at time courses, I'm not sure what those global time courses are called, and what we see with our own changes is that they kind of gradually drift down. But interesting, the positive mode changes can spike right up and stay high for the duration of the scan.
Another thing that's interesting is, looking at the excitation of the layer-5 pyramidal cells as well. So it's a mixed bag, you know. And I think one thing that I'd advise caution as well, and I would say one thing that we shouldn't think too much about is activity going up or down. I think it's a really crude sort of description of a change in brain activity. I think it's a little much more of a brain networks and interactions and things like causality as well in the brain, influence of regions on other regions and influences of networks and other networks and this kind of thing. That's where we want to look, in the futures, much more the kind of dynamics of the brain. Anybody else?
Okay, there's a final question up in the back. While you run up there, I would like to ask a question a little bit related now that Robin says it doesn't matter if it goes up and down. I still have no, it doesn't, not that it doesn't matter, but Robin has seen a relationship between subjective effects and the decrease in the frontal part of the brain. Did you relate any subjective effect to the changes in tracer uptake with SPECT?
No, I didn't.
You didn't look at that, because that would be interesting, because if it's related, the subjective effect in the opposite direction, that's quite interesting.
I wondered if you could comment on the UDD study where I understand that they kind of increased the psychological integration amongst members of the church, I believe they also found that it didn't degrade the serotonergic network in the same way as, say, the SSRI chemicals were. So over time, they're not getting a degradation of the system where taking out some antidepressant customers. Could you explain that mechanism?
Sorry, I didn't hear the end of the question. So you mentioned a UDB study in which they didn't see.
Well, they found greater psychological integration within members of the church undergoing the ceremonies, but I believe they also found that the serotonergic system was enhanced rather than being degraded as it would be by the SSRI chemicals.
You mean the study that Callaway published in the 1990s? They saw an increase in the serotonin transporter in platelets, but I'm not sure how they interpreted these results. Maybe Charles Rock could say something about it. But,
the issue is what can we make of activity on platelets?
Yeah, of course.
It may not correlate that well.
Yeah, the point was it's very hard to, in fact it's kind of pointless extrapolating from the platelet to the human. I mean, the only thing I would say is if you continue taking a monoamine oxidase inhibitor, you will have more serotonin in your brain because its metabolism will be reduced, so that's not a question.
Yeah, and most studies that have been conducted to date on long-term users have not found any deficits in these populations. So ayahuasca would seem quite safe from this point of view.
Thank you very much.